And welcome to the CyberArk Privileged Access Management Administration course. This course is designed to get you started using the CyberArk Privileged Access Management solution, or PAM for short. This lesson introduces the CyberArk Privileged Access Management, or PAM solution. During this lesson, we will look at an overview of basic PAM principles and concepts, a common attack method, and how CyberArk PAM can minimize exposure. Key features of the CyberArk self-hosted PAM solution, the system architecture, system interfaces and utilities, and online help and the customer community. Let's look at the concepts and challenges underlying privileged access management. A privileged account is any account that has the capability to change or impact the operational service of a business process. Therefore, we often refer to privileged accounts as the keys to the kingdom. At CyberArk, we believe the key to defending your infrastructure is to defend privileged accounts, the accounts that are the keys to the kingdom. Some examples of privileged accounts include Windows administrators, Unix and Linux root accounts, sys users in Oracle, and the enable user on a Cisco device. CyberArk's Privileged Access Management, or PAM solution, enables organizations to secure, manage, control, and monitor all activities associated with privileged accounts. It's important to understand that privileged accounts exist in every connected device, database, application, industrial controller, and more. And in modern organizations, there are typically 3 times the number of privileged accounts as there are employees. Until recently, IT admins were considered the only privileged users. Now, almost any identity can be considered privileged under certain conditions. This can include a developer who has access to source code that can easily impact the organization production environment and therefore represent high risk. It can be a third-party vendor that needs to access corporate resources from remote. And it can also be a workforce team member that has access to a financial system with high privileges. Let's look at some of the challenges and threats facing organizations today. Attackers need insider credentials. The first quote here from the Forrester Wave states that 80% of the breaches they investigated involved compromised privileged credentials. The reason the attacker goes after the privileged credentials is because those are the ones that provide the access they need, the control over the IT infrastructure. An advanced persistent threat, or APT, is a stealthy computer network attack in which a person or group gains unauthorized access to a network and remains undetected for an extended period. During that time, they will search for domain admins, local admins, service accounts with domain privileges, and other privileged user accounts in order to exploit their access. The CyberArk PAM solution is centered around 3 easy-to-understand risks, or guiding principles, which make it simpler for customers to articulate the value of what they're doing with CyberArk and why. First, prevent credential theft. How can I ensure that my privileged passwords and keys, both for human and non-human entities, are kept out of harm's way? How do I cut back on the credential residue that exists across workstations, servers, applications, and source code repositories? How do I prevent adversaries, both internal and external, from gaining access to the keys to the kingdom? Second, stop lateral and vertical movement. How can I stop an adversary from pivoting from a non-trusted environment to a high-risk environment? How do I stop them from moving from my on-premise to cloud environments? What sort of web of access exists today that could be used to traverse my environment? And finally, limit privileged escalation and abuse. How can I drive down the number and capability of privileged accounts to reduce my attack surface? How can I control the way in which users gain privilege in order to limit opportunities for escalation? How do I establish a baseline for what privileged accounts should actually be used for, so I know when someone may be abusing them? Looking at identity security in this way gives us a valuable rule of thumb to help us make decisions on when and where to engage moving forward. Always ask yourself, will this use case help prevent credential theft, stop lateral and vertical movement, or limit privileged escalation and abuse? If the answer is no, then it may not be worth your time. Privilege is at the center of the attack lifecycle. Most attacks today follow a similar pattern, with privileged accounts at the center. And understanding this pattern is key to protecting your sensitive data from theft and compromise. Regardless of where an attack originates, whether it's a malicious insider, such as a disgruntled employee, or a targeted external attacker who has broken in through phishing or some other type of attack, attackers will end up on the inside. Once inside the network, attackers first look for access to an internal account, preferably with some administrative privileges. They then leverage the compromised privileged account to perform reconnaissance and move laterally through the network, escalating their privileges at every opportunity, expanding their knowledge of the network topography until they can develop an attack plan to reach the target system or systems. In this threat landscape, the battle to protect sensitive data needs to occur inside the network, and the most effective way to win, to keep sensitive data out of the hands of attackers, is to secure privileged accounts, which are required for any malicious actor to carry out a successful attack. CyberArk breaks the attack chain at its most critical point, at privileged elevation. Because privileged accounts are managed by CyberArk, and therefore rotated on a regular basis, hashes left behind on devices quickly become useless, especially when one-time passwords are used. Privileged elevation is no longer possible, therefore preventing reconnaissance and lateral movement. The attack chain is blocked, and the attacker is confined to a single machine. If no escalation is possible, the attacker will have to find another attack vector, another phishing victim, for example, in another part of the network, or preferably someone else's network, in order to achieve this lateral movement. Each failed escalation is a blocked path for the attacker. CyberArk provides an important layer in the overall security strategy because it delivers both proactive protection and threat detection in the critical path of privileged accounts, the target of every external and insider attack. The CyberArk approach to privileged access management is based on proactive protection, detection, and response. It is a full end-to-end solution that can protect all privileged accounts, regardless of the device type or where it is located. This global approach to protecting privileged accounts involves more than just rotating passwords and SSH keys. CyberArk PAM is capable of monitoring privileged account usage, detecting attacks as they occur, and responding in real time. Proactive protection begins with securing credentials in a digital vault and managing them through policies. Access is limited to authorized users by implementing strong controls over the privileged account credentials, which enforces individual accountability for each action taken using the credential at any time. Privileged sessions also need to be isolated to provide a single control point and to prevent malware from jumping from an administrator workstation to a server. The final step in proactive protection is to limit the scope of user privileges. Each user has privileges to do his or her job, but no extra privileges that could mistakenly be used to inflict damage on the network or maliciously used to cause damage. Another important part of a comprehensive privileged access management solution is targeted detection of unusual or unwanted user behavior. This means that privileged sessions need to be monitored and recorded, and organizations need to leverage real-time, command-level intelligence on what is being done during the privileged sessions. identifying unusual or suspicious behavior for individual users that may indicate malicious or risky activity. Armed with this intelligence, organizations can respond swiftly, and sometimes even automatically, to any detected threats. Let's look at some of the key features of the CyberArk PAM solution. The strength of CyberArk's PAM solution resides in its ability to discover and manage credentials, isolate credentials and sessions, record and audit sessions, monitor privileged activity, and remediate risky behavior. CyberArk PAM has automated processes for account discovery, and there are configurable policies for managing password complexity and length, the frequency of password rotation, and much more. CyberArk enables secure connections to critical systems using a proxy that is fully isolated, thus never exposing privileged credentials directly to the end users or their client applications or devices. This proxy is called the Privileged Session Manager, or PSM for short. Target systems are fully isolated, and privileged credentials are not exposed to end users or their applications or devices. Target systems are configured not to accept direct connections. With the PSM, end users can connect securely in a variety of ways, either through the CyberArk web portal for general access or via a variety of native workflows. While not the most prominent feature of PSM, session isolation is arguably the most important. By dictating that all privileged account activity be channeled through a jump host, we can take better advantage of the network segmentation we've set up to protect our servers from the vulnerabilities of our workstations. First, we create a layer of isolation between our servers and our administrators, who are real-life, fallible humans operating from a workstation network populated with other fallible humans. Avoiding direct connections to servers reduces the chance of malware spreading from a workstation network to a server network. Also, now that all legitimate administrative traffic can only come from a PSM server, the firewalls protecting our server network no longer need to allow connections to a myriad of administrative ports on a myriad of servers from a myriad of workstations. The server network need only accept connections from the PSM servers, alone on a single port. This allows us to simplify and strengthen the firewall rules, protecting certain network segments from the spread of malware or from the lateral movement of attackers, and to easily implement a new layer of protection on our servers. Privileged sessions that pass through the PSM can be recorded in video or text format. These records are stored and encrypted in the tamper-resistant digital vault. The recordings have a clickable timeline allowing auditors to navigate to specific events. CyberArk Session Monitoring enables auditors and security teams to review recordings and to monitor live sessions, which can be sorted based on risk. This enables the security operations personnel to take a risk-based approach by prioritizing the greatest threats that are detected in the environment. CyberArk can automatically rotate credentials in the event of a detected threat. Unmanaged accounts can be automatically onboarded and managed through CyberArk's continuous discovery capabilities. Additionally, administrators can establish policies, either to suspend or terminate privileged sessions automatically based on risk assessment. This table provides an overview of some of the key features available in CyberArk's PAM solution. Features that are available whether your system is hosted on your premises, in the cloud, or a mix of the two. Take a moment to look over the table. When you're ready, click Next to continue. Now let's begin to look at the system architecture. CyberArk PAM is made up of several different components, each with a specific role to play in the overall solution. The main components of the PAM solution are the Digital Vault, a secure server used to store privileged account information. It's based on a hardened Windows Server platform. The Password Vault Web Access, or PVWA, which is the web interface for users to gain access to privileged account information. It is also used by Vault administrators to configure policies. The Central Policy Manager, or CPM, performs the password changes on devices, scans the network for privileged accounts. The Privileged Session Manager, the PSM, isolates and monitors privileged account activity and records privileged account sessions. The Privileged Threat Analytics, or PTA, monitors and detects malicious privileged account behavior. Here we see the Vault surrounded by its dependent components. As we can see, the Vault is the center of CyberArk's privileged access management solution. Most communication among the various components passes through the Vault. On the outer ring sit the various clients of the Vault, the servers and services that require privileged account management. For security reasons, none of these endpoints may communicate directly with the Vault and can only access Vault data by interfacing with one of the CyberArk components. And speaking of Vault security, let's look at some of the elements that separate these clients, these Vault users, from the credentials stored in the Vault, the keys to the kingdom. First, there is session encryption. The Vault communicates with the component servers using the secure CyberArk protocol. This proprietary protocol ensures that only CyberArk components can communicate with the Vault. The CyberArk protocol runs on TCP 1858 or TCP 443. It is based on OpenSSL to provide secure encryption of all data in transit. It can further be encapsulated with TLS for maximum security. Next up, the firewall. The Vault uses the built-in Windows firewall, but sets it up so that CyberArk controls the firewall. CyberArk will only allow incoming communications via the CyberArk proprietary protocol. The firewall normally allows no outbound communications unless the Vault has a specific need to send a message. In that case, the Vault will create a firewall rule to allow the communication, send the message, and then delete the firewall rule, effectively closing communications. The Vault only allows communications needed by the Vault, only at the times needed by the Vault. Otherwise, the firewall denies everything. Authentication. All users must authenticate to the Vault before they can access the stored credentials. The Vault supports several authentication methods, both single-factor and multi-factor. Given the nature of the data stored in the Vault, multi-factor authentication is preferred. CyberArk components establish communication with the Vault by authenticating to the Vault using a built-in authentication mechanism. Discretionary access control. The Vault implements extremely granular, role-based access control, allowing the Vault administrator to configure several different roles within the Vault, like auditor, password user, or Vault administrator, and to assign different users different roles on different collections of passwords. This allows us to fine-tune exactly what a user can see and do within the Vault. Mandatory access control. The Vault implements several system-wide access controls, such as subnet-based or time-based access limitations that apply to all users regardless of their role or privileges within the Vault. Auditing. The Vault records everything that happens to the Vault and stores that data in a tamper-proof audit trail. Furthermore, the Vault can produce alerts on certain events to proactively notify administrators or auditors of suspicious or risky activity for users or components. Finally, file encryption. Every file, or password, stored in the Vault is encrypted with its own unique encryption keys. The Vault maintains all those encryption keys within a key hierarchy with access controls. This ensures strong encryption in which no user has access to any encryption key. As environments grow more complex, the CyberArk implementation must necessarily grow in complexity as well. For enterprises with large, heavily segmented networks or multiple sites and data centers, we often see several instances of all the components for managing all the different sites and network segments, as well as additional instances of components for fault tolerance. Here, we have a high-availability Vault cluster residing in a U.S. data center, with a full complement of CyberArk components to service North American requirements. The Vault cluster is replicated to a disaster recovery site, as are the components. There are additional sites in London and Hong Kong hosting local versions of the components, as well as potentially additional vaults in a distributed vaults configuration to help improve performance. Now let's look at the interfaces and utilities we will use to interact with and manage the solution. The PVWA provides users and administrators access to the contents of CyberArk's Digital Vault. PVWA version 10 introduced a new user interface, which focuses on seamless workflows and easy access. End users will use this interface to retrieve passwords or launch privileged sessions. Auditors will use this interface to monitor privileged sessions. Some features still require the classic interface, which can be accessed by dedicated links. The classic interface is mostly used by Vault administrators to manage policies and permissions, and to configure the PVWA and the other components. The PrivateArk client is the legacy interface to Vault data, mostly used by administrators for certain tasks that are not implemented in PVWA. The PrivateArk client can be installed on any station with access to the Vault. The Pam Web Services is a RESTful API that enables users to create, list, modify, and delete entities in Pam using programs and scripts. The main purpose of the Pam Web Services is to automate tasks that are usually performed manually using the UI and to incorporate them into system and account provisioning scripts. The Vault Server Central Administration Station interface is installed on the Vault host and cannot be installed on other machines. Some of the operations the server interface allows are starting and stopping the PrivateArk server Windows service, displaying the Vault server log, and changing the Vault debug levels dynamically. The remote control client runs from a command line interface and enables administrators to carry out tasks on the Vault server where the remote control agent is installed. The client and the agent communicate through the CyberArk Remote Control Protocol on port 9022. The remote control client reduces the need to open an RDP port for the Vault. Let's look at online help and the customer community. There are a vast array of online resources available to administrators of a CyberArk PAM solution, including our own CyberArk customer community. The customer community allows you to gain easy access to online documentation, a knowledge base, more training, enhancement requests, and the marketplace. The online documentation is available from the CyberArk community. Starting from version 10.10, the online documentation is also publicly available and requires no login credentials. The online help includes easily searchable information from our documentation. Working with CyberArk means that you will need to get a handle on the various abbreviations and acronyms used for its various components and services. CPM, PSM, PVWA, PACLI. All can be found in the online glossary. And now to sum up what we've seen in this first presentation. In this session we discussed the basic principles and concepts, key features of the CyberArk PAM solution, the PAM system architecture, system interfaces and utilities, and the online help and customer community. Here are some additional useful resources for you to review. Now, you may complete the following exercise. Thank you for your attention.